Did you know that the universe is so enormous, humans can't even begin to comprehend its size? Imagine trying to grasp the concept of infinity. It's like attempting to envision a never-ending story, a bottomless pit, or a number that keeps growing no matter how long you count. That's what we're dealing with when we talk about the universe's size. It's beyond anything we can truly understand or put into perspective. The universe is so vast that it makes our home planet, Earth, seem like a mere speck of dust. In fact, it's said to be about 93 billion light-years in diameter. To put that into perspective, a light-year is the distance that light can travel in a year, and light moves at a staggering speed of about 186,000 miles per second. Now multiply that by the number of seconds in a year, and then by 93 billion. The result is a number so large it's effectively incomprehensible. But let's not stop there. Consider our Milky Way galaxy, which is just one of an estimated 2 trillion galaxies in the observable universe. It's so massive that even if you could travel at the speed of light, it would still take you 100,000 years to cross from one end to the other. And remember, that's just one galaxy out of trillions. It's humbling, isn't it? To realize that in the grand scheme of things, we're not just small, we're minuscule, we're insignificant. Yet at the same time, it's awe-inspiring. It reminds us that we're part of something much larger than ourselves, something truly unfathomable and mysterious. So, the next time you gaze up at the night sky, take a moment to ponder the sheer vastness of the universe. Let it humble you, let it inspire you, and let it fill you with wonder. And that's just the tip of the iceberg. Let's dive deeper into the mysteries of the cosmos. Imagine a place where sound doesn't exist. Welcome to space. Here in the vast expanse of the cosmos, silence reigns supreme. But why is space so eerily silent? The answer lies in the nature of sound itself. You see, sound travels as waves, vibrating particles in mediums like air, water, or solid objects. However, space is a vacuum, largely devoid of particles. Without particles to vibrate, sound waves have no medium to travel through, rendering space a silent symphony. Now, if you were to shout out in the void of space, the sound wouldn't travel. Your voice would die as quickly as it was born, swallowed by the vast particle-less expanse. It's a chilling thought, isn't it? To be in a place where even your screams would fall on no ears. So remember, in the grand design of the cosmos, in space no one can hear you scream. What if I told you that about 27% of the universe is made up of something we can't even see or touch? That's right. We're delving into the intriguing world of dark matter, a concept that has baffled scientists and space enthusiasts alike for decades. Dark matter, as the name suggests, is dark. It doesn't emit, absorb, or reflect light, making it quite the elusive entity. But how do we know it exists, you might ask? Well, it's all about the gravitational pull. You see, galaxies would simply fly apart, and stars wouldn't orbit if it weren't for the gravitational glue provided by dark matter. Interestingly, our understanding of dark matter is a bit like trying to make sense of a shadow puppet show. We can't directly see or touch the puppets, but we can make out their shapes and movements from the shadows they cast. This is very much the case with dark matter. We can't observe it directly, but we can perceive its influence on galaxies and clusters of galaxies. The existence of dark matter was first postulated in the early 20th century by Swiss astronomer Fritz Zwicky. He noticed that galaxies in a cluster were moving much faster than they should be. He postulated that there must be some unseen mass, or dark matter, causing this. Yet, despite its vital role in the universe, dark matter remains a profound enigma. We don't know what it's made of, and we can't observe it directly. Some scientists believe it's composed of yet undiscovered subatomic particles, while others suggest it might be made of primordial black holes. The truth is, we just don't know. The quest to solve the dark matter mystery continues, with researchers around the globe tirelessly working to crack this cosmic conundrum. From particle physics experiments deep underground to telescopes probing the farthest reaches of the universe, the search is on. The invisible force that holds our universe together, dark matter, remains one of the greatest mysteries in cosmology. Who knows? The answers to this enigma might just redefine our understanding of the universe and our place within it. Light, the fastest thing in the universe, takes over 100,000 years to travel across our galaxy. Imagine this. You're zipping through space at the speed of light. That's about 186,000 miles per second. You'd be able to circle around the Earth more than 7 times in just a blink of an eye. That's incredibly fast, isn't it? But here's the thing. Our Milky Way galaxy stretches over 100,000 light years across. Even if you could travel at light speed, it would still take you over 100,000 years to get from one side to the other. That's longer than the entire history of human civilization. It's a humbling thought, isn't it? Even as we master the speed of light, the cosmos remains vast and largely unexplored. Even at light speed, space makes us feel the vastness of its expanse. Space is not just silent, it's deadly too. With its striking appeal and stunning visuals, space might seem like a tranquil haven from afar, but it's far from being a hospitable place for us humans. Firstly, let's talk about air, or rather, the lack of it. The vacuum of space is devoid of air. Now you might think, well, I'll just hold my breath. But that's not how it works, unfortunately. If you were to hold your breath in space, the air in your lungs would expand, leading to a rather grim outcome. Without air pressure to keep your body intact, you'd be in for a rough ride. And it's not just the lack of air that's a problem. In space, there's no atmosphere to scatter sunlight, which means one side of your body could be scorched by direct sunlight, while the other side could be freezing in the shadow. It's kind of like having one foot in an oven and the other in a freezer. Not the most comfortable situation, is it? The extreme temperatures are another aspect that makes space deadly. Space isn't uniformly cold. When in direct sunlight, temperatures can soar to boiling points, while in shadow, they can plummet to bone-chilling lows. But wait, there's more. Space is also a sea of radiation. Without the protection of our planet's magnetic field and atmosphere, your body would be bombarded by cosmic rays. This radiation can cause serious damage to your cells, leading to all sorts of health problems. In essence, the beautiful cosmos that we admire from our safe, warm homes is a deadly vacuum. It's a place of extreme conditions, where the lack of air, the harsh radiation, and the drastic temperature swings make it an inhospitable environment for humans. Yet despite its deadly nature, space continues to captivate us, beckoning us to explore its vast expanse and uncover its secrets. After all, it's in our nature to venture into the unknown, to push our boundaries, and to seek out new frontiers. Space, the beautiful yet deadly final frontier. Despite the countless stars, space is darker than the darkest night on Earth. It's a mind-bending paradox, isn't it? With billions of stars illuminating the cosmos, one might expect a brilliant light show. But alas, the universe is predominantly dark. This cosmic darkness is largely due to the vast distances between celestial bodies. Light from distant stars takes an incredibly long time to reach us, and some of it never does. The universe is also expanding, which means that many stars are moving away from us, their light red-shifted into obscurity. Furthermore, interstellar dust and gas can absorb and scatter light, further deepening the cosmic darkness. So, while our night sky may twinkle with a smattering of stars, remember that what we see is a mere fraction of the universe's stellar population. In the grand theater of the universe, darkness has the main role. The universe is not static, it's expanding every second. Let's dive into this. When we mention the universe's expansion, we're talking about an idea rooted in the Big Bang Theory. This is not just a popular sitcom, but an astrophysical concept that posits the universe began as an infinitesimally small, infinitely hot, infinitely dense singularity, roughly 13.8 billion years ago. From that singular moment, the universe has been expanding, growing larger and cooler. Imagine a balloon being inflated. The surface of the balloon represents the universe, and as you pump more air into it, the surface expands. Now, consider this. The galaxies in our universe are akin to dots on the surface of that balloon. As the balloon expands, the dots move further apart. This is how our universe expands, galaxies drifting apart in the cosmic sea. But how do we know this? It's thanks to a phenomenon known as redshift. When we observe distant galaxies, we notice that their light shifts towards the red end of the spectrum. This shift is due to the expansion of the universe stretching the wavelengths of light, and it's a telltale sign that those galaxies are moving away from us. So, as we sit here contemplating the cosmos, remember this. As we speak, the universe continues to grow, making itself even more mysterious. Nothing in the universe can travel faster than light, or can it? That's the question that has been puzzling scientists for centuries. Let's dive right into this cosmic conundrum. Albert Einstein's theory of relativity set the cosmic speed limit at the speed of light, approximately 186,000 miles per second. That's fast enough to zip around the Earth 7.5 times in just 1 second. Now that's zippy, but here's where things get interesting. Some theories challenge this cosmic speed limit. One such theory is quantum entanglement, a phenomenon where particles become interconnected and can instantly affect each other, regardless of the distance between them. This instantaneous interaction seemingly defies the speed of light limit, causing many a physicist to scratch their heads in wonder. Another challenger to the cosmic speed limit is the concept of wormholes. These theoretical passages through space-time could potentially allow for faster-than-light travel, essentially providing a shortcut through the universe. Imagine that, a cosmic shortcut. But it's important to remember, these are just theories. The speed of light remains the fastest confirmed speed in the universe, a speed limit that even the most powerful of cosmic phenomena, like black holes and supernovas, must obey. So for now, the speed of light holds the title as the ultimate speedster of the cosmos. The cosmic speed limit, another enigma in the cosmic playbook. Ever wondered what it feels like to be weightless? In space, you can find out. This fascinating phenomenon is due to microgravity, a state of very low gravitational force. Now, imagine yourself free from the pull of gravity, floating effortlessly. This isn't a magic trick or a figment of imagination, but a reality for astronauts in space. Microgravity gives you a sensation of continuous freefall, like that heart-stopping moment on a roller coaster. Only it never ends. It's like diving into an endless ocean, where up and down lose their meanings. Your body, unburdened by its own weight, floats freely, and every movement feels like a swim in the air. But remember, being weightless isn't as easy as it sounds. It takes a toll on the human body, affecting muscle strength and bone density. Despite the challenges, it's a unique experience that truly defies the laws of nature we're accustomed to on Earth. In space, we all can fly. As we conclude our journey, remember, space is the ultimate mystery, waiting to be unraveled. We've embarked on a cosmic voyage, unraveling 10 astonishing and spine-chilling realities of this vast universe that we inhabit. We've ventured from the unfathomable expanse of the cosmos to the silent symphony of starlight, each revelation a testament to the grandeur and enigma of space. We've grappled with the enigma of dark matter, that elusive entity making up about 85% of the universe's mass, yet remains unseen, only making its presence known through its gravitational pull. We've marveled at the speed of light, the fastest thing in the universe, and yet, in the cosmic arena it seems almost sluggish, highlighting the sheer scale of the cosmos. We've delved into the deadly vacuum of space, a realm where no life as we know it can survive without the aid of technology, a stark reminder of the universe's lethal nature. We've stared into the unending darkness, a stark reminder of the infinite vastness that lies beyond our planetary home. We've explored the ever-expanding universe, a phenomenon that challenges our very understanding of space and time and pushes the boundaries of human comprehension. We've discussed the cosmic speed limit, the ultimate velocity that no object can exceed, a fascinating testament to the laws that govern our universe. We've floated in the weightless world of space, a realm where up is down and down is up, a place where our earthly notions of orientation cease to apply. Each of these facts paints a picture of a universe that is grand, mysterious, and deadly in equal measure. In the grand scheme of the cosmos, we are but tiny specks of stardust, exploring the infinite mysteries of the universe.